Well, now let's divide radical expressions. So pause the video and work these problems, then come back and check and see how you did. This one's pretty easy. The square root of 4 is 2, square root of 9 is 3. And over here, square root of 1 is 1, and the square root of y to the 4th, if you have 4 of them and you want to know how many groups of 2 do you have, well, you've got 2 groups of 2. Our key concepts. When we're combining radical expressions, we have a quotient. It can be rewritten both ways. The square root of n over a divided by the square root of n over b can also be written as the square root of n a over b. And then rationalizing the denominator is rewriting an expression so that there are no radicals in the denominator and no fractions in any radical expression. Let's see what that looks like. All right, we're to divide and simplify. Well, since these both have the same index, we can rewrite them under one radical sign. Negative 81 divided by 3 is negative 27. The cubed root of a negative 27, negative 3. Again, same index, we can write them under one radical. 192 divided by 3, 64. X to the 8 minus 1, because we have x's on the numerator and the denominator, we have to simplify that. X to the 7th. Well, how many groups of 3 can we get out of here? Well, 2 groups of 3 with 1 left over. And we can rewrite 64 as 4 to the 3rd. So we can pull out a 4 and an x squared. That leaves an x under the radical, because we pull out any groups of 3. Okay, we're to simplify this one. Same index, so we can write them under one radical. Then let's begin simplifying. We have an x in the numerator and the denominator. Now we can't leave a radical in the denominator, so let's split these two and rationalize the denominator. Multiplying both the numerator and the denominator by the square root of 3y. That will leave us under the radical 3xy. And down here, 9y squared, which is 3y. So square root of 3xy over 3y. One more example. We have the cubed root of 5 over 4y. Now notice we're not multiplying by 4y. We want to have perfect cubes. So if we take 4 and multiply it by 2, we could get 8, which is a perfect cube. And to make y a perfect cube, we need 2 more. So that's why we're multiplying by the cubed root of 2y squared instead of the cubed root of 4y. We're trying to get this to a perfect cube. 5 times 2 is 10, y squared. And as I said, the cubed root of 8 is 2, cubed root of y to the 3rd is y. And on the numerator, the cubed root of 10y squared. Okay, let's do a little practice now.